Hello and welcome back. This is Noah again, and we're going to go through the now you try problem for absolute value functions and doing application introductions here. So in this case, we're looking at the speed. We just read it. Speed and velocity are pretty much the same thing, except for speed is always thought of as positive, while velocity can be positive or negative to indicate the direction of an object, forward or backwards. Also, it could be up or down, and that's actually what we're going to look at here. So suppose a ball is thrown upward, and its velocity is given by v of t equals negative 32t plus 64, where t is time in seconds, and the velocity is given in feet per second. Here, a positive velocity means the ball is going up, while a negative velocity means the ball is going down. Now, the speed of the ball is the absolute value of the velocity and will not tell us whether the ball is going up or down. It'll just tell us how fast it's going in whatever direction it happens to be going at that moment. In this case, speed is given by the function s of t equals the absolute value of negative 32t plus 64. Again, time is in seconds and speed is in feet per second as we look at this. So we want to create a table of values for s, the speed, around t equals 2, going by half seconds. And we're going to graph s of t using this data. So let's make a table of values here. I have t in my first column, speed in my second. So we'll say 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and we'll try and squeeze 4 in there once we're at it. So let's do this off to the side. S of 0 is going to equal the absolute value of negative 32 times 0 plus 64. So that is going to equal just 64 once the 0 cancels out the negative 32. S of 0.5 is going to equal the absolute value of negative 32 times 0.5 plus 64. This is going to give us 32 times 1 half is 16. 64 minus 16 is 64 minus 6 is 58, minus 10 is 48. So the absolute value of 48 is just 48. S of 1 is going to equal the absolute value of negative 32 plus 64, and that will simplify to just 32. S of 1.5 is going to be negative 32 times 1.5 plus 64 equals absolute value. So this, if we look and start looking for a pattern, it goes 64 and 48 and 32. These are going down by 16. So the next is going to be 16. And then S of 2 is going to be negative 32 times 2 is negative 64 plus 64. This will simplify to 0. So let me fill these into the table. 64, 48, 32, 16, 0. And now as we pass 2 for the time, S of 2.5, it's going to equal the absolute value of negative 32 times 2.5 plus 64. And negative 32 times 2 is negative 64, and then we need another half of that. So it's going to be negative 16. Oops. Sorry, positive. It's going to be negative 16 plus 64. And we can double check that on a calculator if we want to. And then that's going to give us, no, that's definitely not negative 16. Look at this. Arithmetic's hard. Okay, this needs to equal 16 when we're done. That's going to be a negative 48 in there. Yeah, that makes sense. Okay, 2 times 32 is 64. Wait. I know why. This is going to be negative Let's just do this longhand. Everybody loves longhand, right? 32 times 2.5. We can ignore the decimal for now. 5 times 2 is 10. Bring the 1. 5 times 3 is 15, 16. And then 2 times 2 is 4. 2 times 3 is 6. We'll add them all up. 0, 0, 1, 8. And then we need a single decimal, so that's 80. That's negative 80 plus 64. There we go. That equals the absolute value of negative 16, which equals positive 16. I'll do one more. S of 3 is going to equal negative 32 times 3 plus 64. Negative 32 times 3 is negative 96 plus 64. It's going to be the absolute value of negative 32 equals positive 32, and we can start seeing that pattern now. So it's 16 for 2.5, 32 for 3, then it's going to go to 48, and then 64, and we see that symmetry around when t equals 2. All right, let's get a graph up then. So everything's positive, and we're worrying about t equals 2, so let's get this off to the left. We'll go here. All right, let's do 1, 2, 3, and 4. And we need to go all the way up to 64 here. So let's do every grid line is worth 8. So then I'll do 2 grid lines is 16, 4 grid lines is 32, 6 grid lines is 48, 8 grid lines is 64. That way we can kind of see what we're doing here. All right, so the first point we're going to do is 0, 64. And then we want 1/2 48. So 1/2 is right here, 2 grid lines to the right, since I'm making 4 grid lines worth 1. And we want 1, 32, then 1/2, 16, then 2, 0, and then 2.5, 16, 3, 32, 3.5, 48, and then 4, 64. And we'll draw our line here. All right, we're going to leave the graph starting at the point 0, 64, because that's the moment that we throw the ball. Let's get some units on here. The vertical axis is s for speed in feet per second, and the horizontal axis is t, time, in seconds. So we want to talk about how inputs and outputs are behaving. We can use GeoGebra to confirm our graphing's correct if we need to, but this is the graph we should get. And we're going to do more on graphing these by hand here in following videos. So how are its inputs and outputs behaving? As the time of flight approaches 2 seconds, the speed drops is decreasing. We'll say at t equals 2 seconds, the speed is 0, and let's say feet per second. As time passes 2 seconds, the speed increases. And so what's happening is as the ball is falling, right? So during the first part of the flight, as it's thrown up, its speed is slowing down, slowing down, slowing down until it reaches the top of its flight path, at which point the speed is 0, and then it falls back to Earth. Gravity pulls it back down, and the speed starts increasing and increasing again. We now want to know, when does the ball have a speed that is less than 32 feet per second? It's strictly less than 32 feet per second. So what we'll do is we'll say, okay, our 32 feet per second speed line, this is where speed equals 32 feet per second. And we have these intersection points at 3, 32 and at 1, 32. And so from this, we can see that the speed, the red line, is under 32 when the time is between 1 and 3 seconds. The ball's speed is less than 32 feet per second between the 1 and 3 second marks. During its flight. All right, and that's what we're going for here. Sorry about that arithmetic flub there. I'm sure you guys have had your own. No worries there. All right, thanks so much for watching, and I will see you in another video. Thank you much.